5. And we said if it was the left-tailed or right-tailed, and table 5 is nice because it does the one-tailed, two-tailed. And we don't have to divide anything. We don't have to do anything with this. We do have to do n-1 degrees of freedom. Remember, everybody gets that choice of freedom except that last one. So n-1 for degrees of freedom. We found our cutoffs. We got that far. Found our cutoffs, our critical values. Now, we talked about your test statistics. Your test statistic is exactly the same. Your p-val in this one, if you use your calculator, you get your p-val. Your p-val is a little difficult because your table doesn't do a p-val thing. It works the opposite way from your z-scores. Okay. We state your claim, your level of significance. We use your critical values. We label your reject regions, and a lot of you guys like the reject regions. We make a decision. Again, we follow the chart for your decision. So we did this one, right? We did that one together. God bless you. We're going to do this one. Okay, sample 5 on page 368. All right. An industrial company claims, here's your claim, that the mean, mu, pH level of water in a nearby river is 6.8. There's your claim. The mean is 6.8. Is that the HO or the HA? HO. It's got the equal sign. What's the HA? Is not equal. Good. So what tail test do we have? 2-tail test. So right away, let's sketch and label your 2 tails. Reject H0 in both of your tails. And fail to reject. Remember the reject H0 has these small errors, so that's got to be the smaller part of your curve. Okay, the sample. We did a sample here of 19 water samples. 19, that's pretty small, that's less than 30, right? And we only know that sample mean and that sample standard deviation. That sample mean was 6.7 and that sample standard deviation is 24.24. Is there enough evidence to reject? Reject had to be the HO. Yep, it was our HO. The company's claim at a level of significance of 0.05. Now they're telling us to assume your population is normally distributed because you have a small sample. When it's greater than or equal to 30, it automatically is normally distributed. But if it's less than, they have to tell us that. Because if you remember your flow chart, if it's not normally distributed, you just kind of stop. So we have like no hypothesis to test if we had to stop. So they have to tell us this along the way. Now, you need to find your T sub 0 down here. One's a negative, one's a positive. So you go to your table 5, A18, your blue margin, A18. You look for your degrees of freedom. What would your degrees of freedom be? 18. You follow your 2 tails for 0.05, and you find your cutoff value. Find your critical value form. 2.101. Now, 2.101. On the left side of the 0, it is negative. You're only getting one. One's a negative, one's a positive. Again, your curve is symmetric. So this totally makes sense to us. Now, we test your Z test, your T test. Your T test says the X minus the mean over the standard deviation over square root divided by the square root of n. Same thing we did for your Z. So we take your sample mean minus your population mean over your standard deviation divided by the square root of n, not the degrees of freedom. Make sure you use n. So we plug that in, and we get a t-score of negative 1.82. and we look to see where that places on our graph. Go by the 0. It's just a number line. So it falls to the left of the 0, but not as far as this. Negative 1.82. There's your t. That's called your test statistic. You test it with your sample, and that's what you get for your t-square. So therefore, your decision is fail to reject 80. Works the same exact way. Now, we follow your chart. If we fail to reject the null, and the null was the claim, we kind of agree with it, right? We take it for good. But we say, HO, fail to reject, there is not enough evidence to reject the claim that the mean pH level of the water in the nearby rivers is 6.8. Good with that? Now, you can absolutely use your calculator. Stat, test, instead of z-test, drop one down. T-test. You can use your t-test for this. Now, before when we tested your p-val, we can't get the exact of your p-val. We can get close, but we can't get exact because of the way your table is set up. We can figure out your areas between, but we can't really get that exact. But your calculator does return you a p-val with this. So if you put it in your t-test, you can get your p-val back from your calculator, and you can test. Figure out your answer and test against your 0.05. And you can test exactly in that chart the way we did before. Same thing. You can bypass doing your t-test statistic with your calculator. Make sure you set your tails up the same way you did what you did. It works the same exact way. And the calculator knows how to find your t-score. It does its own internal table. It's a far more exact than your table is. Questions? Okay, you try it yourself, number 5. I want it set up just like this. So here's this company, still making claims here. It also claims that the mean conductivity of the river equals 1890 milligrams per liter. Okay, the mean is, this is their claim. Is this the HO or the HA? HO. HA says not equal to. So again, we have a two-tailed test. This is your reject H0. This is your fail to reject H0. The conductivity of a water sample is a measure of the total dissolved solids in the sample. You randomly select, there was your 19 water samples, and you measure the conductivity of each. The sample mean is 2,500 milligrams per liter, and the standard deviation is 700 milligrams per liter. Is there enough evidence to reject? Reject tells us HO. Yep, we're the HO. The claim at a level of significance of 0.01. The time their error that they're allowing the maximum is very small. Assume your population is normally distributed. So did you find your critical values? Anybody find a critical value? Let's get Cam.
Negative 2.878.
So negative 2.878 and positive 2.878. Okay, we agree? All right, good so far. Now what? You do the T. We want our test statistic. We want to see where our information falls. So you have your square root of n. You have your sample mean. You have your population. Has to be positive because the sample mean is larger. Standard deviation. So what did we get for a T? 3 points.
Negative 3.8. Yeah. I got positive.
It's
positive.
positive.
3.7 million. In the calculator, you get positive.
Well, you have to remember, guys,
You round
if
it up.
the sample is above, it almost needs its own sketch. Here's your population mean. Your sample is well above it. It has to be positive, right? It has to be positive. It's falling to the right somewhere. So your Z-score, T-score has to be positive. So 3.79? Good? Okay, now, that falls way into your reject zone. Even though the level is small, it falls in your reject H0. Okay, so now you're not liking the claim. So you follow your chart. If you reject H0 and your claim was H0, there is enough evidence at a level of significance of 0.01 to reject the company's claim that the conductivity of their river is 1890 milligrams per liter. Good? Everybody can do this? Okay. Now, did you get me a p-val? Put it in your calculator. Your calculator returns your T and returns your P. It's the only way for you to get a p-val.
Yeah, 0.001.
0.001, thank you. It gives you your p-val. Now, if you're going to test your p-val against your level of significance, test it in this order. Put your level of significance here and fill it in with zeros. Or make it match. I don't need the extra zero. So therefore, is 1 less than or equal to 10? Yes. This was your decision. Reject H0. Your calculator's nice because it gives you your p-val. Yes. Yes, you gotta know how to do both.
How do you do the p-val again?
Put it in your you gotta put it in your calculator. Go to test, go to stat, test. Second one down, t-test. That's the one thing you have to use your calculator for. You
Yeah,
can
but where's
estimate
that
it.
one?
Hmm?
M1.
And put your information in.
I did.
Your U is this guy, 1890. Your X, 2500. Standard deviation, N, and then follow the tail. To tail, not equal, calculate. Did you see it?
Yeah, no, I didn't get O1. Gave me
P equals. Everybody do that? Okay. So P is very, very small here. Okay. Hold this up a minute. 2 things to do. On page 371, the first 3, make sure you test them using reject region. Don't forget, I want claim, same as we've been doing, HOHA, sketch, you do your t-test, your t-statistic, and p-val for this guy. That's when you're going to have to do on your calculator. Okay, and then make your decision and interpret it. Interpret it.